Okay, today we're going to be looking at arithmetic series, often called arithmetic progressions. I'm not quite sure what the difference is, but hold on. An arithmetic series is one with the first term, let's call it A, and then it goes up in the common difference. So you've done it at GCSE, you've done nth terms at GCSE, it's nothing new there. There's just a little bit more to it at the moment. So if the first term is A, it's got a common difference of D, the second term is A plus D, the third term is A plus 2D, the fourth term is A plus 3D, and so on. Notice the number of D's is always one less than the actual term, so the last term is A plus n minus 1 lots of D. So we've got, we write L for the last term, sometimes written as UN, equals A plus n minus 1D. I like to use a general term. If a term's got, if a sequence got 10 terms, then n is 10. N isn't 1, 2, 3, 4, 5, 6, 7, 8, no, 9, it's 10. But so if I want to know the value of the ninth term, I prefer this as my general term one. It's different than what you did at GCSE. For what we're doing at the moment in this video, you can get away without using this, but I prefer it for the next stage if you use this. So our kth term is A plus k minus 1d, as we'll see in a moment. So, a couple of examples then. If we've got a series that goes 5, 8, 11, 14 and so on, it's going up in threes. I know that A is 5, D is 3, and if I want the 25th term, it's a good idea to remind myself what I'm doing. It's A plus 24D, using this. So it's 5 plus 24 times 3, 72 plus 5, 77. There. The kth term then will be 5 plus k minus 1 times 3. You leave it like that, or you can times it all out to get 3k minus 3 plus 5. And that's what you would have done as the nth term for this pattern at GCSE. 1b starts at 4, goes down in sixes. So the 25th term then, yet again, is A plus 24d, which is 4 plus 24 times minus 6 minus 144 plus 4 minus 140. And as I say, the kth term then is A 4 plus k minus 1 times minus 6. So I've got minus 6k plus 6 plus 4 plus 10, or 10 minus 6k. And that's very similar to what you would have done as an nth term at GCSE. Let's have a look at a couple more then. So in this case we're given the first term, the second, the third and the last term here. So I can use this here. So I'm going to formalise it in this case here. I'm going to use the L equals A plus n minus 1d to say that 127 is 7 plus n minus 1 times, it goes up in fours, 4, and undo it. So n minus 1 is 127 minus 7, 120 over 4, which is 30, n equals 31 terms. I could have done it by going, well, from 7 to 127 is a difference of 120. Since it's going up in fours, how many fours make 120? 30. 30 gaps mean there's 31 terms. You've got to take that logical step though, if you're doing it in this informal way, to go from the fact that I've got 30 gaps to 31 terms, whereas this, I use my formula, solve it, there's my answer. This is now beginning to get towards your typical question you're going to see. We're given in words, the third term is 7, the ninth term is 31, and I can shorthand it to this, U3 equals 7, U9 equals 31. And we're asked to find A and D. Now, you can fudge it. You can say, to go from the third to the ninth, I go up by 6 lots of the difference, so 6 lots of the difference make 31 minus 7, 24, so the difference must be 4, and then go backwards there. What it's going to be harder to do, the next video we'll do, is about the sum of series, and you can't fudge it if you're given the third term is 7 and the sum of the first 9 terms is 115, say. There's no way in the world you can sort of just use a bit of common sense and fudge between it. You have to set up formal equations and solve them simultaneously. So to get into that habit, we'll do that here. U3 equals 7. I know that U3 equals A plus 2D equals 7. And U9 is A plus 8D, which is 31. And if I do 1 and 2 and say 2 minus 1. And as we say, we get 6d equals 24, d equals 4, and stick it into the first one, a plus 8 equals 7, a equals minus 1. So there's my difference and there's my first term. I can check in the other one, 32 minus 1 is 31, so they're my answers. As I say, you can fudge it for this question, but I want you to set up simultaneous equations and get used to using those at this stage so you can do it when it gets harder later on. Last example, not a great deal to this little part here. I'm given a series 3, 10, 17, 24, so it starts at 3, goes up in 7s, and I want the value of the term so that the term itself goes over 1,000. What position in the series gets me the first one over 1,000? So I'm going to solve a plus k minus 1d equals 1,000. I'm not going to probably get a whole number answer, so I'm going to have to round up no matter what the answer is there. And so stick in 3 plus k minus 1 times 7 equal 1,000, and then so 7k minus 7 plus 3 minus 4 equals 1,000, k equals 1,000, and 4 over 7. Let's have a look what we got there. And it goes 143 point something, 143.4 something. So it's not a mathematical rounding off. I need the fact that k is the 144th term. That's the first one that will go over 1,000. The 143rd will be less, the 144th will be above. And so, as I say, at the moment, looking at just initial part of the arithmetic series, that's the typical sort of things you might see, these last two examples. When we talk in the next video about the sum of series, you'll see it becomes a bit more complex, and we have to use the formula that I said before.